Welcome. My name is Rosemary Whittle, and I'm a PhD candidate at the University of Guelph, Canada, and my poster is about whether omega-3 maternal diets improve cognitive performance of broiler chicks in a T-maze test. Firstly, I'm going to give some background to my research. Omega-3s are polyunsaturated fatty acids, or PUFAs. The main food sources of omega-3s include oily fish such as salmon and mackerel, algae such as seaweed, and plant-derived oils such as chia and flaxseed. It may be also important to note omega-6s, which are found predominantly in plant-based oils such as corn, soybean, and safflower. Both of these are essential fatty acids necessary for human development. However, these two groups of PUFAs compete for the same fatty acid desaturase. Therefore, overconsumption of omega-6s may inhibit the metabolism of omega-3s. I'm going to talk a little bit about the evolution of the human diet. Diets of modern humans differ vastly from those of early human hunter-gatherers. The diets of these early humans was dictated by the availability of seasonal food, mainly meat, fish, plants, and wild grains. Their diets were rich in omega-3s, especially in coastal regions. There are even debates as to whether omega-3s might have been one of the driving forces of human brain evolution. Modern humans, especially in the West, eat a highly processed diet, largely deficient in omega-3s. This began due to the agricultural revolution, allowing for high production and easy access to grains for the wider population. Omega-3 deficiency in humans has been linked to decreased brain volume, particularly in the white matter, hippocampus, amygdala, and corpus callosum. Omega-3 deficiency has also been linked with many mental health and cognitive issues, including schizophrenia, depression, anxiety, Alzheimer's, Parkinson's disease, autism, and ADHD. In addition, several physical health issues have been linked with omega-3 deficiency, including chronic heart disease, cardiovascular disease, cancer, diabetes, and atherosclerosis. You might ask, why would we then choose to feed omega-3s to chickens? Chickens are vastly better than humans at metabolizing omega-3s. Therefore, wide consumption of chicken meat and eggs by the population make chickens the perfect conduit to aid in increasing the population's consumption of omega-3s. Flax seeds can be fed to chickens with little to no adverse effects on the birds. It also has little effect on the sensory quality of eggs and meat. Feeding flaxseed to laying hens can lead to a 20% increase in the inclusion of omega-3s in eggs, and to broiler chickens can lead to up to a 250% increase of omega-3 inclusion into the meat. Whilst omega-3 chicken products may benefit our health, it is important to know what the effect of feeding omega-3s to chickens may have on them as well. My research looks predominantly at maternal-fed omega-3s and the effect this might have on the behavior and welfare of their offspring. Previous research into omega-3 supplementation in chickens has shown that omega-3s increase cognitive ability, especially in spatial cognition tasks. They have also been shown to modulate inflammatory responses, reducing the severity and prevalence of keelbone fractures in laying hens and improving leg health in broilers. One negative effect of feeding omega-3s is that it has been shown to increase fearfulness, especially in novel environments. I want to take this research one step further by targeting the parents of our commercial birds and seeing if we can improve the behavior and welfare of laying hens and broilers solely through omega-3 supplementation of their mothers. If you enjoyed this introduction to my project, please visit poster number 2, where I am presenting the results of a T-maze test from my broiler trials, where I tested the effect of maternal-fed omega-3s on their broiler offspring. Thank you for listening to my presentation.